Hello and welcome to this applied acid-base titration question, which has both a dilution and scaling factor incorporated into what's going on. This gives it a little bit of extra mathematical challenge. So here's the question, and it starts off by describing the steps that the student takes when they analyze the household cleaner containing dissolved ammonia. So let's take it a step at a time. And what we need to do is visualize, either in our heads or maybe even better, drawing it out on the screen or on paper, what each step means. So if we take our household cleaner, 25 centimeters cubed of that is diluted to 250 centimeters cubed. Now normally in chemistry, the piece of equipment we use for dilution is what's called a volumetric flask. So I'm going to give you one of those as a diagram here. So 25 centimeters cubed of the household cleaner goes into the volumetric flask, and then distilled water is added, so it dilutes it up to the 250 centimeter cube mark. The next thing it says is that 25 centimeters cubed of the resulting solution is titrated with 0.125 mole per decimeter cubed of sulfuric acid, and 24.40 centimeters cubed were required to reach the end point. So continuing with our visualization, we take 25 centimeters cubed of our diluted cleaner we've just made. We transfer that to a conical flask and set it up as a titration. The burette contains the sulfuric acid, and 24.4 centimeters cubed were needed. So I'm going to use the data moles, equation moles, answer approach. Now you'll notice I haven't put answer as a little subtitle on the side there. That's because we're going to try part A and part B first, and then come to the answer section of the sequence to come up with answers to part C. So first thing is the amount of H2SO4. Now I'm going to start with that because I have the information needed. I have the volume and I have the concentration. So it's simple, N equals V times C. So you first of all convert the volume into decimeters cubed. The reason being that the concentration is in moles per decimeter cubed, so you have to compare like for like. And then you multiply that volume in decimeter cubed by the concentration, which is 0.125, and that gives you 3.05 times 10 to the minus 3 moles. Now you can see in the equation that the number of moles of ammonia is double the number of moles of sulfuric acid, so therefore you put that in the equation part of your working, 2 to 1. So that must mean that I need to double my number of moles of ammonia. So multiplying 3.05 times 10 to the minus 2 by 2 gives me 6.1 times 10 to the minus 3. There you go. That's the screenshot from my calculator. Now, the next thing to do is to think about what the concentration of the ammonia in the household cleaner. So when they say the household cleaner, they're talking about this. So we now have to think backwards. We've got the number of moles of ammonia here. First thing to do is work out how many moles of ammonia were in this sample here. Now the number of moles of ammonia in the cleaner is the number of moles titrated, which is here, scaled back up. So 250 divided by 25 is obviously times 10. So that turns 6.1 times 10 to the minus 3 into 6.1 times 10 to the minus 2. So where we are now is the number of moles here. Now we're not quite at the number of moles inside this container here. So to do that, we need to make the number of moles in the cleaner divided by the volume. So the concentration in the cleaner is the number of moles in the cleaner, which is here, divided by 250 over 1,000. Now, that gives us 0.244 moles per decimeter cubed in 250 centimeters cubed. Now, this came from here. So you need to think carefully, what happens to the volume as you go from 250 to 25? So the number of moles is the same, but the volume is 1/10. So there's the same moles packed into 1/10 of the volume. So we multiply the concentration up. So that means the actual concentration inside the original cleaner is 2.44 times 2.44 moles per decimeter cubed. I'm just showing you my original calculation here. It's obvious I can do this one in my head. It's quite straightforward because you're just going from 250 down to 25. But the thing to remember here, the number of moles of ammonia here is the same as the number of moles of ammonia that was transferred from the 25 centimeters cubed. Now we're assuming, just to make things easy, that there's 25 centimeters cubed in total in this plastic dispenser. All of it goes into here. You make it up to the mark. You take 1/10 of that, you titrate it. Okay, now we've got the answer in moles per decimeter cubed. What about in grams per decimeter cubed? So what you do here is you multiply the moles per decimeter cubed by the MR. Now the MR of ammonia is 17, so 2.44 times 17 gives you 41.46 grams per decimeter cubed. Okay, hopefully this has given you an insight into how to think your way through one of these questions. I strongly recommend that when you're doing them, you make the effort to draw out what you believe is happening, and then that helps you to trace it in your head. It parks it on the paper in front of you, rather than it rattling around in your brain. You're trying to sort of think backwards all the time. That's what makes it easier. Okay then, as always, thanks for listening. Until next time, see you soon.